way that gives mankind all the benefits of this unusual timber, while at the same time retaining the natural beauty of the forests and improving the prospects for the tree crop in years to come. Here at the Hammond Lumber Company operation at Big Lagoon, portable chainsaws bite through the giant redwood trunk, and it's timber. With the history extending from the days of the Holy Roman Empire through the Crusades, the discovery of America, and the landing of the Pilgrims, this and other giants that can grow no more must now be cleared to provide growing space for the younger trees. These logs are destined to be put to a new use for redwood. They'll be transformed into light, strong, insect and rot-resisting plywood with the characteristic soft reddish color of this unique wood. While plywood has been made of other types of lumber for years, redwood until recently proved too costly to process, and the results were unsatisfactory. Now, the M&M Woodworking Company of Portland, after 4 years of research, has established a $2 million plant at Eureka, California, in which redwood plywood can be manufactured. Here, the logs, cut into workable 8-foot lengths, are first cleared of bark. The logs, selected for uniformity and freedom from knots, are tenderized with steam that permits the lathes to shave off continuous plies in thicknesses ranging from 1 to 5/16 of an inch. The veneer moves along a conveyor under fluorescent lighting, past a man known as the Clipper Man, whose sharp judgment of wood and trigger-fast reaction enable him to cut out defective or imperfect sections, leaving clear sheets to be sorted and graded. From here, the veneer will go to dryers, a critical operation in the production of redwood plywood, for this wood contains 40% water, 95% of which must be eliminated. Now we're ready to form the plywood, a sandwich of many layers of veneer alternately laid crosswise and lengthwise to give great strength and protection against splitting. Special bonding agents had to be perfected by M&M to avoid deterioration of the redwood's natural color caused by ordinary glues. After undergoing pressure of 150 pounds per square inch at high temperature, the permanently bonded panels are trimmed, sanded, and again graded. And so the tree that was a seedling in the time of Charlemagne at last completes its cycle by going to work in the service of man.
In America, we are likely to wake up to the music of a radio clock, arrive at work in a precision-built train or a mass-produced automobile, sit at a desk or stand at a machine in a centrally heated and air-conditioned building, come home to a delicious meal made with frozen foods, telephone friends and family anywhere in the country, enjoy an evening of television, and go to sleep in pajamas made of synthetic fabrics under an electric blanket. We Americans live in a scientific world where we have used our technical developments to increase the living standard of all Americans.
The century-old H.B. Smith Company of Westfield, Massachusetts. Let's drop in on these veteran makers of cast iron boilers, whose experience dates back to pre-Civil War days, and see how they keep up with the times. The inside of a modern boiler is a maze of water tubes and flues designed to wring the maximum amount of heat out of the fuel and, at the same time, not be so bulky as to take up half the basement. These men are preparing a core for the mold. The oil-treated sand is formed into the internal shape of one of the boiler sections. Long years of experience have given the highly skilled H.B. Smith craftsmen their deft touch and patient attention to detail. The integrity of these old-timers is one of the company's proudest assets. While the core is baking in the dryer, the top and bottom of the mold are prepared to receive it. They'll determine the outside contours of the boiler section. A machine called a sand slinger assures uniform pressure around the metal pattern. When the pattern has been removed, the core is gently lowered into place. the greatest accuracy is required if the walls of the boiler section are to be of uniform thickness throughout. Now, the top of the mold can be set in place, and again, much depends on the reliability of old hands, who use modern production techniques with the pride in their work that comes only with time. The mold is complete, and into it will now be poured white-hot liquid iron from a double-lip pouring ladle. The temperature of the metal at this stage averages about 2,700 degrees Fahrenheit. Removed from the mold, the casting has been cleaned of hot sand and other debris inside and out, but still must undergo extensive machining and testing. Openings are reamed and tapped, and the section made ready to fit perfectly with the other sections. Though boilers are customarily assembled only at the site where they'll be used, H.B. Smith assembles one occasionally to run special tests and seek possible new improvements like those that have transformed their product from this to this and this. It's their youthful, ever-progressive point of view that has kept these veterans in step in the forward march of industrial progress.
A Beechcraft Bonanza at Wings Field, Pennsylvania, is fitted out with a complete radio navigation, communication, and instrument landing system, all packed into this tiny 18.5-pound compartment. The Narco Omnigator, latest product of the National Aeronautical Corporation of Ambler, Pennsylvania, allows the owners of personal and executive planes to negotiate in bad weather with the assurance of a commercial airline pilot. Starting out in business only 7 years ago, the three young founders of Narco have encountered gratifying demand for their lightweight, low-cost instruments to make small plane flying safer and more convenient, even in weather like this. With the nationwide network of Omni-Range ground stations now operated by the CAA, the device allows the pilot to determine exactly where he is in relation to one or more of those stations, not just by listening for the station signal, but visually as well. The old-fashioned, low-frequency radio range system has many limitations and is often ineffective during storms, just when it's needed most. The Omnigator, using very high frequencies, is always clear, static-free, like FM radio. Heading for the ground station located at an airport, we emerge into clear weather lined up with the runway. We just get clearance from the control tower and take her right on in. Just a few of the electronic marvels crammed into this newest age to aviation.
For the last dozen years, inflation has reduced the value of our 100-cent dollar until today it's only worth 53 cents. There are four things all of us can do to stop inflation and protect the value of our money. First, build production. Turn out more goods in every hour we work. Second, back the Federal Reserve System's credit controls. Third, boost a pay-as-we-go tax system to make sure the government balances its budget. And four, ban government waste by making sure every dollar the federal government wants to spend is spent wisely. Let's beat inflation and build a sound, healthy dollar.
Here's a group of typical American boys who've invented not just another way of enjoying themselves, but, as Mother and Dad are likely to point out, a new way to wear out shoes. Giving greater life to the footwear of hard-playing youngsters and their hard-working elders is the goal achieved by the O'Sullivan Rubber Corporation of Winchester, Virginia. Here, rubber and other ingredients are processed into a rubber-based synthetic composition for heels, soles, and a broad line of molded rubber goods. After weighing, first stop is the Banbury mixer, where it's thoroughly, uniformly blended. Going into this hopper are the carefully measured ingredients for soling slab materials that will go to shoe manufacturers to be cut into soles for new shoes. But the ingredients have a lot of processing to go through before they'll be ready for the bottom of a shoe. On calendars, they're rolled thinner and thinner. As it's calendared, the material is constantly blended on large mills. Finally, it emerges in a wide, continuous sheet of unvarying thickness throughout. The sheets, half a dozen at a time, feed from great rolls into the dynapress, which vulcanizes the layers together in a non-stop operation. A silicone solution sprayed intermittently keeps the composition from sticking to the rollers. This amazing machine produces enough O'Sullivanite each month to provide the soles for more than 1 million pairs of shoes. In making molded items like heels and replacement half soles, punch presses stamp out rough preforms called biscuits, which are cooled to prevent premature vulcanizing. Many different sizes and types of biscuit are required to allow the filling of the most varied orders. Preparing the molds for the face of the heel is more complicated, especially in the production of a heel called the Aristocrat, which is inlaid with 3 composition inserts to give longer wear and prevent the heels from running down at the edge. Little spikes projecting from the mold will leave openings for nails, and to make sure those nails really hold, tiny metal washers are placed on the spikes to become embedded in the center of the heel when the heel is molded. Under 1,000 tons of pressure and 320 degrees of heat, 30,000 pairs of heels can be produced on just one press in a single day. Many of those thousands go to the armed services, mostly, of course, the Army. A jet of air lifts the heels out of the mold. Excess rubber is trimmed off or flashed, and the finished heels are ready for packaging. In pairs, they're placed on a moving belt that boxes them automatically. For centuries, when man wore any shoes at all, he walked on heels and soles of wood, leather, cotton, rope, or other natural product. It was modern industrial resourcefulness that gave him shoe bottoms made of a material with greater resilience, vastly increased wearability, that grip better, won't mark floors, and cost less in the bargain.